So we've got a tank of water, and we know that water's flowing in at this rate here. So that tells you in a given minute how much water or how much the volume is changing by. So that's the rate of change of volume per minute. And that's going to be positive because we're adding to the volume. But we also know that water is leaving the tank at this rate here. And you'll see that this rate, the rate at which water is leaving the tank out of this tap at T, it depends on H, the height of the water. And that's because as H goes down, the flow rate out of T, the tap, is going to go down as well because there's less pressure pushing the water out the bottom of the tank. So our aim is to try and come up with a differential equation with dH by dt in it. So we want to find an expression for the rate of change of the height of the water with respect to time. So the first thing that I'm going to do, and this is like a really common type of question, I think the easiest thing to do is just write down what you know from reading the question. So the first thing I'm going to do is I'm going to deal with the rate of change of volume. Okay, so I'm going to say V is the volume in the tank at a given time t, and these two highlighted pieces of information here are to do with the rate of change of volume with time, so dV by dt. And a little tip, if you ever get confused what derivative these are related to, look at the units. So this is meters cubed per minute. So on the top, we've got something to do with the volume, and on the bottom, we've got something to do with time, a unit of time. So this is how is volume changing with time, which is why it's dV by dt. So water is flowing into the tank at this rate. So that means that in a given amount of time, the volume is going to increase, so this is positive, by 0.84 pi meters cubed per minute. But water is also leaving the tank at this rate. Now, because water is leaving the tank and it's going to make the volume go down, we need to subtract this amount of water that's leaving the tank per minute. So that's 0.6 pi h. Well, we can't quite find dH by dt yet. So we've got to think about another equation that we can write. Well, we know that it's a cylindrical tank, and we can find an equation which links H and V. So often in these questions, you're going to be able to write an equation. Well, we've got an equation at the moment with dV by dt in, but we want dH by dt. So that means that we must be able to write an equation that links V and H, and you'll often get that in exam questions. So if we think about this volume of water in the tank, the volume of the water in the tank is just going to be the volume of this grey cylinder here in this question. So the radius of the cylinder is 3. So we can use the formula for the volume of a cylinder. It's going to be pi times by the radius squared times by the height of the cylinder. Or we could write that as 9 pi h. So now we've got an equation linking V and H, which is what we needed. So we want dH by dt. That's what we're aiming for in part A. So what we're going to do is we're going to use the chain rule, and we're going to work out dH by dt is going to be dH by dV multiplied by dV by dt. Now the reason why we need an equation linking V and H is to get this dH by dV. So as soon as we've got an equation with V and H in it, we can differentiate it with respect to H. So dV by dH equals 9 pi if we differentiate with respect to H. So that means that dH by dV is going to be the reciprocal of this, which is 1 over 9 pi. So that tells us that dH by dt is going to be 1 over 9 pi multiplied by dV by dt, which we worked out before, is 0.48 pi minus 0.6 pi h. And now all we've got to do is try and get it in that form that the question wanted us. So the first thing to realise is we can cancel these pi's if we multiply this bracket by 1 over pi. And then I'm going to times through by 9. So we're going to have 9 dh by dt equals 0.48 minus 0.6h. Now we want 75 at the start in front of times by dh by dt, not 9. So I'm going to times through by 75 over 9. And if you do that, then you are going to have 75 dh by dt equals 4 minus 5h. So my step there was I times both sides by 75 over 9. So then for part B we need to find the particular solution. So we're told when t equals 0, h equals 0.2. And we're asked to find the value of t when h equals 0.5. So from part A we've got this differential equation. So we need to solve this differential equation to find an expression for h in terms of t, and then we'll be able to solve part B. So now we're going to solve the differential equation using the method of separating the variables. So I'm going to divide both sides. I'm going to get all the h's on the left hand side. So I'm going to divide both sides by 4 minus 5h. So on the left hand side I'm going to have 75 divided by 4 minus 5h dh, and on the right hand side we'll have 1 at that point, and then I'm going to times by dt. So really I've got 1 dt there. So now we can integrate both sides. On the right hand side, if I integrate 1 with respect to t, I'm going to get t plus a constant of integration. And on the left hand side, we can do this by using a substitution. So on the side, I'm just going to try and work out what this integral is. So I'm going to use the substitution u equals 4 minus 5h. So we know du by dh is equal to minus 5. So that means I can replace dh, if I rearrange this to get dh as subject, as minus 1 over 5 du. So this integral can be written as the integral of 75 over u times by minus 1 over 5 du. And then 75 divided by minus 5 is minus 15. And then we've got the integral of 1 over u du, which is just log u. So we're going to have minus 15 log u, but u was 4 minus 5h. We've got minus 15 log of 4 minus 5h. So next we need to work out what this value of c is, this constant of integration. And we're going to use the fact that when t equals 0, h is equal to 0.2. So we're going to sub in those values there. So when t equals 0, h equals 0.2. So that tells us that we're going to have minus 15 log of 4 minus 1 equals c. So that tells us that c is equal to minus 15 log 3. So that tells us that our equation linking h to t is minus 15 log of 4 minus 5h equals t minus 15 log 3. And I should probably mention here, we don't need to rearrange it to get h the subject. We're not asked to do that, so we're not going to do it because we might make a mistake if we try and do that. So we're going to go back to the question on what we were asked to find. We were asked to find the value of t when h is equal to a half. So now we're just going to sub in when h is equal to 0.5. Let's find out what t is. So we're going to have minus 15 log of 1.5 equals t minus 15 log of 3. So we can rearrange this to get t the subject. T is equal to minus 15 log of 1.5 plus 15 log of 3. So remember, we're probably looking for an exact value because we're in pure maths here, although we could also give a decimal approximation. I'm going to take 15 outside of a bracket, and then I'm going to have log 3 minus log of 1.5. And then I'm going to use a log law to write this as a single log. So I can write that as log of 3 divided by 1.5. Well, 3 divided by 1.5 is just 2, so it's 15 log 2. And we can give an approximation, so that's approximately 10.4.